Welcome back, everyone. Today we are going to be finishing up Chapter 10, 10.6, Solving Right Triangles. So again, we're going to solve a right triangle. In the past, we've been talking about sine, cosine, and tangent. Now what we are going to be doing is the inverse of each. So what I want you to do is I want you to write down the bottom piece, not the top, but write down the bottom piece of this slide, please. Do so now. All right, now if we look at this this slide here, it says at the top, if you know sine, cosine, and tangent of an acute angle measure, you can use the inverse trigonometric function to find the measure of the angle. So if we were talking about finding the sine, cosine, tangent of an angle to get the length of a side. Now we're going to use the side length to get the angle. We're going to be going backwards. We're going to be doing the inverse. So again, at the bottom it says if sine of A is equal to x, then the inverse, and again that's just that -1, sine to the -1, talking about the inverse sine of x is equal to the measure of angle 1. On your calculator, you'll see a little sine button, your sine, cosine, and tangent. If you hit second and then sine, or second cosine, second tangent, that gives you your inverse operations. Okay, so we're going to try a couple. So angle A, please write this down. Make sure you write down the directions as well. If you don't want to write angle, just remember, you can do that angle symbol, same thing there. Okay, it says angle A is an acute angle. Use the calculator to approximate the measure of angle A to the nearest tenth of a degree. So if we look at the tangent of angle A is equal to 0.71, on your calculator, I want you to hit second, tangent, and that second sign should give you the tangent of tangent to the negative first, and you're going to put in parentheses 0.71 or just 0.71. Okay, when you come out to your answer on your calculator, you should get 35.37475,184. Okay, so that should be the answer you come out to get on your calculator. All right. So the tangent, take second, tangent, type in 0.71, hit enter. This is the answer you should come up with. So rounded to the nearest degree, nearest tenth of a degree is going to be approximately 35.4 degrees. Okay, don't forget your degree symbol. So again, second, tangent, 0.71, write out your answer. Again, you make sure that your mode is in degrees, not radians. Put your mode in degrees. Alright? So if we look at the bottom one, the tangent of A is equal to 2. So again, on your calculator, you're going to take tan, the second tangent, put 2, and you're going to get a long decimal. When you round that to the nearest tenth, you get 63.4 degrees. Again, it's going to be degrees, so 63.4. Alright. Again, if you didn't get those answers, make sure it's in degree mode, and then solve. Alright, so here's our first problem with a right triangle. So what we are going to do, and there's actually an X up there. Okay, what we are going to do is we're going to solve this right triangle, and when we solve this right triangle, we want to find the missing angle measures and the missing side measures. Okay? So initially what we want to find is going to be angle D, angle F, and DF. Okay? Angle D, angle F, and angle D, side length DF. Okay? What I'm going to do is I'm going to start with the easiest one, which is DF. Look, we have a 90-degree angle. We have two sides, so if I know two sides and I have a 90-degree angle, how can I figure that out? Pythagorean theorem. A squared plus B squared equals C squared. Gotta love that Gotta love that formula. Absolutely love it. Okay, now we plug in A. What is A? 2.1 squared plus, what is B? 5.3 squared equals C squared. Okay, when we add 2.1 squared plus 5.3 squared on your calculator, you will get 32.5 is equal to C squared. How do you undo that squaring symbol? Square root. Okay, so C squared, approximately, C squared is going to be, or C is equal to 5.7. So what I just figured out is X, that's 5.7. Alright, so X is equal to 5.7. Now what I have to do is find my angle measures. Alright, I'm just going to cross DF up there, so I know I'm done with it. Okay, now we need to find D and F. We already know this measure. We already know this measure, those two sides. We also know what angle E is. What is angle E? 90 degrees. Okay, 90 degrees there. So now what we have to do is find D and F. And it says at the top, use the inverse tangent to solve. So we know the tangent. We know what tangent is. So what I'm going to do, and this could be, you could go either way. Okay, you could find the tangent of D or you could find the tangent of F. So what I'm going to do, I'm going to solve the tangent of D. Okay, so in your head, I want you to think the tangent of D is equal to, okay, tangent of D, TOA. T stands for tangent, O stands for what? Opposite, A stands for adjacent. So it's got to be the opposite over adjacent. TOA, SOHCAHTOA, TOA. So that means it's going to be 5.3 over 2.1. Okay? Because I came up with my opposite measure over my adjacent measure. Opposite over adjacent is tangent. So if I look at this, now I have the tangent, but I do not have the angle measure. Okay? I need to find the angle measure. So on my calculator, I'm going to type in second tangent, which is the inverse tangent, of 5.3 over 2.1. So inside that parentheses, you will take 5.3 and divide it by 2.1. When we do so, okay, you will get a very, very, very long decimal. 68.38522105714. A very, very long one. Okay, I'm going to just round it to the nearest degree. Doesn't tell me what to round, but normally it's either to the nearest degree or nearest tenth of a degree. So let's say it's the nearest degree. So I have 68.3, which is 68 degrees. So D, angle D, is going to be 68 degrees. Alright? What I'm going to do next is I am going to, instead of doing that whole thing over, I'm going to use my head and I'm going to solve an easy way. Okay, how do I solve? Well, I know the angle sum theorem is going to be 90 plus 68 minus 180, or complementary angles. Both of those have to add up to 90 degrees. So I'm going to take 90 minus 68. What's 90 minus 68? 22. So angle F is equal to 22 degrees. Okay, so this angle has to be 22 degrees. If angle D is 68, angle E is 90 degrees, F has to be 22 degrees. And that makes sense because if you look at the side lengths, okay, 2.1 and 5.3, obviously the opposite of each one has to be relative to its size. Okay, so the opposite of angle F has to be smaller than the opposite of angle D. In fact, it's got to be less than by quite a bit. Okay, questions, concerns. Otherwise, make sure if you have a question, bring it to me tomorrow so I can answer it. Alright, so the same idea goes for cosine and sine. Okay, so at the top, use a calculator to approximate the measure of angle A. Again, you can use that wonderful angle measure or angle sign to the nearest degree. Now we're going to the nearest degree. So when I look at this, I want you guys to give this one a shot. Again, you're going to be using the inverse of each one. So second cosine, second sine. See what you come up with. All right, so if I take the cosine of A is equal to 0.05, I'm going to take the cosine of -1 is going to be times 0.05, and I get approximately, again, nearest degree, I will get 87.13401602. I'll say that nice and slow. 87.13401602. So if I round that to the nearest degree, I get 87 degrees. Again, if it's something different than what I had come up with, it's going to be, make sure your mode is in degrees, not radians. Okay? Second one, sine of A. We need to take the inverse sine of A, which is going to be the inverse of 0.67, which is about, this one, a little smaller, 42.0670648. If I round that to the nearest degree, and nearest degree, 42 degrees. Again, when I take the inverse of a length, I'm finding the degrees of each angle. Okay? If I took just the cosine of an angle measure, I'm finding the degree. In this lesson, we're finding the angle measure using the inverse trigonometric ratios. Okay? Alright, so let's try this one. It says solve for the right triangle. So again, you're looking for the information you don't know. So what I want you to do, what information don't I know? Well, I don't know ST. I don't know R. And I don't know angle T. I know everything else in this triangle, but I don't know those three pieces. So what I want you to do is you can use any trigonometry ratio that you want. It's going to come up to, if you go through the correct steps, it'll come up to the same answers I have. So let's see what you come up with. All right, give this one a shot all by yourself. All right. So hopefully we'll see if you got everything right, and we'll just check our answer right now. Okay, so our very first thing is I want to find that ST. Okay, so I'm going to figure out my leg is 5 squared plus x squared is equal to 5.7 squared. When I bring this up, I get 25 plus x squared is equal to 32.49. When I subtract each side, I come up with 7.49. Take the square root. Look at those colors. Red, white, and blue. Patriotic. Okay. X is equal to, roughly, again, approximate 2.7. So, I know that the angle of measure, or the measure of ST is going to be 2.7. About 2.7. Okay, so now because it's about 2.7, I want to use a trigonometric ratio that uses the information that was already given, which is 5 and 5.7. We know two trigonometric ratios that uses the hypotenuse. Which ones are they? I hope you're thinking sine and cosine. Okay, so it all depends on which ones you want to use. All right, I am going to use the sine of t. Okay, sine of t. Now you might be wondering why I am using the sine of t, which is so opposite over hypotenuse. So SOH, opposite over hypotenuse. Now you might be wondering why am I using sine? Okay, I want to use a trigonometric ratio, like I said before, that's going to use both 5 and 5.7. The reason why I want to use 5 and 5.7 is because those are exact answers. This 2.7 here, that's an approximate. So when I use an approximate in my trigonometric ratio, my answer might not line up perfectly, might not be the same. So be careful. It will be close, but I would use these two numbers. Make sure you use 5 and 5.7. If you use 2.7, not a big deal, but try to use the information that they already give you. Okay, so back to the problem. I need to find the inverse sine of 5 divided by 5.7. Now, the reason why I put both 5 divided by 5.7 is because I want to find out an exact answer. I could divide 5 divided by 5.7 and round that off, but why? I might as well use the exact answers to find out my exact answer. So roughly, if I took the inverse sine of 5 over 5.7, I will come up with 61.3 degrees. So the angle measure of T is 61.3 degrees. I know that that's 61.3. Okay? Because of my complementary angle theorem, because of my triangle sum angle theorem, I can just subtract that 61.3 from 90. When I do that, I get 28.7 degrees. So I know that angle R is equal to 28.7 degrees. Okay? So when I looked at this, I used the information that the problem already gave me. First I found the side measure, then using the information the problem gave me, I solved for T and R. Now, I could have also used the cosine of R, in which I would have had the cosine of R of 5 over 5.7, okay, and I would have come up with my angle R originally. Okay, from there I would have subtracted that to get my angle T. Doesn't matter how you figure out the problem. Okay, you could use, in this problem, I would have suggested to use sine or cosine because those are the measures I was given. But you can use sine, cosine, or tangent to come up with your angle measure. It's up to you, whatever you're comfortable with. If you have questions, we are done for today. If you have questions, bring them in tomorrow. If you're not quite sure how to type it into your calculator, let me know tomorrow. Make sure you write down, I hope you wrote down these notes, which I will be checking, okay, to figure this out. So again, remember SOHCAHTOA. Just want to go over this one more time. Opposite over hypotenuse. Adjacent, you do need to know this, over hypotenuse, and opposite over adjacent. Okay, and remember, this is the inverse of sine, inverse of cosine, and the inverse of tangent. A little info, that's the arc sine, arc cosine, arc tangent. Just another name for it. Don't need to know that, just a little extra there. So again, you're pressing second sine, second cosine, second tangent. Questions, bring them in tomorrow. Have a nice night.